all our technology. The pallet mover is also based on our 3D navigation. But on pallet mover, we do another interesting thing, which is the pallet detection itself is typically the tricky part of pallet movement solutions. And we not only use a great AI model, which is vision-based for pallet detection, but we supplement it with our 3D LiDAR so that the accuracy really goes in the high triple nines rather than something which is typically vision-only solutions do something like 99% accuracy, and we would really do 4 nines or 3 or more accuracy on pallet picking. So that's really something on the pallet picking side we've done very well. Our pallet mover picks up to 3,300 pounds. So I think when we came in, we were quite a pioneer in thinking that AMRs should go anywhere and work on any kind of surfaces. And that is becoming more and more true over time for all other people also. I think, largely people generally believe that mobile robotics and self-driving car technology are kind of part of the same house. So usually you would see more 3D sensing happening. There's more suspension in terms of wheel tolerances, etc. There's more ground clearances in robots for these reasons. So I think these are some of the things both in the mechanical domain and in the sensor domain that you see much more vision and LiDAR getting fused to do things rather than relying on only one kind of sensor. I think the 2D LiDAR is probably something which should be on its way out. I think there is a little bit of a legacy overhang in terms of the 2D LiDARs coming in. They're all safety certified 2D LiDARs that people try to reuse, but the certifications, etc., were really from a different field. Initially 2D LiDARs were made for safety curtains, for robot cages, and AMRs are not really what they were designed for, but they were retrofitted. But I think now the AMR standards are also evolving, and I think the designers, the way the designers are approaching overall design is evolving, where you take a holistic approach to safety rather than relying on just one sensor. For many reasons, we do the robot ground up firstly, right? So from everything from the electronics to the mechanical design to the software, it's all a full stack development done with this goal in mind. But a big role is played by our 3D navigation technology, where we use 3D LiDARs for very dense 3D maps of the environment, which makes us very tolerant to all kinds of changes, and we don't need extra aids like reflectors or QR codes in the environment to help us. Typically, when we went to customers, the first thing we noticed was that robotic makers would typically give you the robot and a long list of things that the robot needs to do its job. And our aim from day one has been that our list is made of exactly 0 items. We don't want our customers to change anything for robots to work, and that's where our mindset of taking self-driving cars as a reference. The self-driving car doesn't ask you to change the road, and similarly we don't ask any of our customers to change their flooring, to put any markers. We are in more than 70 factories worldwide. We don't have a single sticker anywhere guiding our robots. So the speed is dynamic based on what the environment looks like, where the obstacles are. The autonomy software will automatically regulate the speed within the bounds of the safety requirements. So we always try to comply to the best safety standard in our space, which is the ISO 3691 standard. So we've always complied to the same. So the total cost of ownership for our customers is basically, we give the robots on a RaaS model, so robot as a service. So they don't have a payback period really. They make money from month 1 of owning these robots. So there's basically no total cost of ownership calculation and seeing what's your payback period like. All our customers are saving money from the first month they put in the robots. The robots are used 3 shifts and are absolutely very, very affordable to own.